Thank you. So once again, my name is Matej. I work as a software engineer at the company called Cralogics. We are an observability vendor. I mostly work on the collection side of things, so I deal with agents and actually also OpenTelemetry Collector, which partly inspired this talk. But in my previous work and in my open source contributions, I also worked within the Prometheus ecosystem. I worked on Thanos, but currently it's mostly OpenTelemetry, so I thought it might be an interesting combination to talk about this today. So what we'll talk about, we'll take a look at the current status of both ecosystem, where they are, how they compare. Then we'll dive right into talking about what is the famous OpenTelemetry Collector and its pipeline. We'll talk about how we can receive and export Prometheus metrics with this collector. We'll also look partly at how we can then further automate this. If you're running on Kubernetes, there is an OpenTelemetry Operator that you can use. And we'll look at how this relates to Prometheus metrics as well. And we'll end up with some summary and some wrap-up. So current status, we have two projects. What do we see when we look at them side by side? OpenTelemetry, we hear it left and right. This new emerging standard and ecosystem is touting itself to be cloud native, vendor neutral. It's under the auspices of CNCF, same as Prometheus. But when it comes to its definition, for me, it's always kind of elusive because it cuts through so many aspects of observability. I cannot sum it up better as a collection of different things that are named there, but we can start from the collector, where some people see OpenTelemetry as a kind of synonym with the OpenTelemetry Collector, which is the implementation of how OpenTelemetry imagines the collection and processing and exporting of telemetry data. But it's much more than this binary, this piece of code. It's also a very robust specification that tells us how things should and should not be implemented. It comes with its own protocol for transferring data, the OpenTelemetry protocol, or OTel for short. There is a whole set of SDKs, instrumentation libraries, and so on for all the languages that you can desire. And very importantly, the data model is also different from Prometheus world. Because Prometheus, we could say the Prometheus data model is simpler and serves its purposes, but because OpenTelemetry tries to be kind of a more all-encompassing standard or project, it needs to also accommodate for other protocols. So the data model is a bit more complicated. There are more things within this model. I named some of them here, and we might go through them during the presentation. But I think it's the important takeaway is that we need to make a bit of a mental shift from the model that we have in Prometheus. Most importantly, storage is not part of OpenTelemetry. This is left out completely outside of the scope of the project. So this is up to you, whether you want to use some SAS offering, you want to run your own hosted solution, whatever is the format that you want to send your data there, this is left up to you. On the other hand, we have our beloved Prometheus that is near and near to our hearts, staple in the monitoring world with its well-known exposition format, with its world-famous TSDB that we all love, and which also serves as a basis for the distributed versions of Prometheus, Cortex, Thanos, Mimir. And it comes with a robust community that takes care of numerous exporters and other tools that help us streamline our infrastructure and automation when it comes to Prometheus workloads, so namely the Prometheus Operator. So then why are we talking about these two? So we're here at the PromCon, and now there's this guy who's talking to you about OpenTelemetry, like what is he doing here? Is he trying to convert you? Or who let him on the stage? And my short answer is I'm not trying to convert you. I'm not claiming that one is better than the other. I think everyone needs to look at these projects and answer the question for themselves, whether they, what are the pros and cons, whether they think it makes sense to switch or not, whether you might, for example, value maybe the unified experience that OpenTelemetry brings for all the major signals, or the flexibility that comes with the OpenTelemetry collector and its pipeline and how it allows you to maybe transform data and use various deployment patterns. But on the other hand, you might value more maybe your existing experience with Prometheus, maybe you value its stability. It's a battle-tested horse. It's been around for long enough. So I think this is up to everyone. But even as we've seen in the last 2 days, I think the overlap between these two worlds and the collaboration is inevitable. We heard a talk yesterday from Jesus and Gautam, where we learned that Prometheus also intends to become a native solution for storage for the OpenTelemetry protocol. And we've seen also increased interest from within the Prometheus community in regards to adoption or usage of OpenTelemetry. We had at least 2 lightning talks yesterday by Daniel and Hayo. We're talking about or comparing OpenTelemetry and Prometheus in certain specific aspects. So I think that the overlap is undeniable, and I think it will only grow in the future. So I hope that if you're considering OpenTelemetry, or you're interested, or you're just curious, that I can give you kind of an introduction and high-level overview of how OpenTelemetry, when it comes to metrics collection, how it compares to Prometheus, and what is how it also functionally compare with each other. So now that we have the intro out of the way, let's get into the actual collector and looking at what is collector. So as I mentioned, this is kind of the implementation of OpenTelemetry, how it collects or receives, processes, and exports telemetry data. It's a binary. We can just call it whether it's a collector or an agent. It's something that sits somewhere in your infrastructure and collects telemetry signals. As we'll see, we'll go through the whole pipeline that we have here from left to right. So we'll start with our instrumented applications. And in this case, there's no need for change, or there's nothing novel here. We still keep using our applications that are instrumented with Prometheus, that are exposing the metrics endpoint. So from this perspective, there's nothing that needs to be changed, or there's nothing new. On the other hand, using the collector gives you also possibility to introduce some other protocols. So for example, if you would opt to instrument your applications with the native OpenTelemetry SDK, you can send metrics in the OTLP format, or you might want to use some other protocols. Maybe you have some parts of your infrastructure that are not using Prometheus, but rather some other protocols. I have a statsd here as an example. So this also collector makes it easier to receive data in these other protocols. Now the collector itself, we'll talk about a couple of different types of components that are part of the collector. I will focus on the 3 that we see here. It's the receiver, processor, and exporter. And I'll talk about each of these in a moment. But basically, for our mental image, it's just important to know that how the pipelines go from receiver to processor to exporter, and then ends up in your backend. So first of all, the receivers, as the name suggests, they receive the telemetry data, and quite simply, their main task is to translate the format that it's coming from into the internal representation of the telemetry data, which is called pipeline data, or sometimes for short P data. So whatever the format is that is coming in, it will always be translated into this internal representation. Then it's used inside of the collector. So we have receivers that use both pull and push-based approach. So this is again something that won't be changing from what you're used to in Prometheus. Again, we'll still see the Prometheus receiver using the pull-based approach, so it will be just scraping the data. But in addition, again, if you have some other protocols, which might be push-based. You also have push-based collectors receivers in the collector. Processors, I won't talk too much about processors, but basically they allow you to process the telemetry data, to manipulate it, transform in some ways, maybe remove some series labels and so on, do some filtering, batching, and so on. Exporters, these are then the other side of receivers. So on the other end, they are responsible for translating the internal representation of the data into the protocol that can be understood by the backend that you're sending this to. So again, if you want to send, for example, data into Prometheus or Thanos Mimir Cortex via remote write protocol, for example, we would use remote write exporter, and this will take care of translating and sending the data, also including all the other properties that are common for clients, so it can also retry or queue the data for sending and so on. For illustration, here I have a very simple, this is how a configuration of a collector can look like. So it's just a good old YAML. If you go from top to down, you see we have 4 different sections here. The first one is receivers, where we define our receiver. So in this case, we want to receive data in the OTLP format. We're exposing 2 endpoints, one for gRPC and one for HTTP. And we also define processors that will want for us to batch the telemetry data. And lastly, we have a simple debug exporter defined, which will simply put out the data on a standard output in this case. So if you look at the last section, services, and under that the pipelines, you will see that we're defining pipelines per each signal. So we have, in this case, we want traces and metrics. So as you see, the telemetry data will go through the pipeline from the OTLP receiver, then it will be batched by the processor, and lastly, it will be output to the standard output with the debug exporter. And one more example here, just for example, if I decided to also add the Prometheus exporter, so there you can see I have it defined under the exporter section. And again, now just if you look to the very last part of the service section, the metrics pipeline, again, I want to receive the data in the OTLP format, I will batch it, but in this case, I will export it to both for the debugging purposes, to the standard output, and also to the Prometheus. So the collector and the pipeline gives you a power to kind of mix and match different types of receivers and exporters or protocols, or maybe you might want to send the telemetry data to different backends supporting different protocols, or you might even have multiple pipelines per each signal. So it really gives you that flexibility and those possibilities of manipulating the data and sending it where you want in whatever format you want. So then we'll look at the particular receivers and exporters that are relevant for Prometheus. We'll be looking at the Prometheus receiver and related simple Prometheus receiver, and kind of a special type of receiver, or it's called receiver creator. And then with exporters, we'll look at exporter and remote write exporter and see what they do. So Prometheus receiver is actually nothing too complicated. Again, it's intended to be as a drop-in replacement for your Prometheus. So if you take a scrape configuration from your Prometheus and you put it as a configuration for the Prometheus receiver, it will be able to understand it. It's kind of a one-to-one, it's not even translation, it will be able to understand the same configuration. So the receiver actually reuses the same components for scraping as Prometheus. So all the features that you want, you have available, like service discovery, authorization, relabeling, and so on. And if you opt for using the simple Prometheus receiver. This is kind of a wrapper around the Prometheus receiver itself, but is used for single target. So if you look into that, it's like a simplified version of the Prometheus receiver, so it might be interesting for you. Now, just again, for illustration, you can see nothing complicated. This is just a portion of the config that I was showing previously. So this is just showing the receivers, and we'll just define the Prometheus receiver, and you can see the scrape config must look familiar to all of you. We define some jobs. We have one static job that's scraping the collector itself, and then we're using Kubernetes service discovery. We have some relabeling configuration there. So all familiar. Receiver creator, I think it's an interesting possibility also within the collector. It's not a receiver by itself, but it can conditionally create other receivers, and therefore also Prometheus receiver at runtime. And this is based on discovering networking endpoints discovered by so-called observers. Observers are another component that are part of the collector, but they don't deal with the telemetry data themselves. They are just serving this purpose of discovering those endpoints. So whether you use Kubernetes, Docker, or you just run it on your physical host, there are observers available for different environments. And then these leverages rules and variables that can be used to conditionally define and run the receiver. So here I again took an example from the collector repository, where you can see that we define, in the receiver section, we would now define receiver creator, and we would want it to watch for the Kubernetes observer. And again, in the receivers, we define receiver as previously. So we kind of have now two levels of configuration for the receiver. It's becoming a bit maybe less clear. But then in the Prometheus simple, the definition of the Prometheus simple receiver, we have the rule, and we see that under this rule, we would want it first to look for the type to be pod, so this kind of corresponds to the endpoint type. So in this case, we're looking for pods. And if the pod has an annotation, prometheus.io/scrape, it will create the receiver for this endpoint. As you can see also in the configuration, you can reference, you can also conditionally reference some variables or some values from your annotations and use them to set the endpoints and other configurations. So it can be interesting for some use cases. The other side of the collector, the exporters, there are two that are relevant to us. There is Prometheus exporter and Prometheus remote write exporter. The first then, the Prometheus exporter, this exposes metrics in the Prometheus format for scraping. So this will expose them on the metrics endpoint as we're used to, and it has besides other configuration, it has configurable metric expiration. So depending on how long you don't see metric coming in, it will unregister this metric and it will not show up in the metric endpoint anymore. The second one, the Prometheus remote write exporter, is again the configuration is very similar to what you would see in your Prometheus agent or other solution you might use for remote writing. So it just simply sends remote write compatible backends. There you have some options to fine-tune your remote write, how it queues the data. It also supports WAL, although write-ahead lock, although I think currently there are some issues around it. So if you look into that or if you use it, then be mindful of that. And one important caveat is also, this goes back to the differences in the data model, especially if you would be looking into ingesting metrics that are not Prometheus native, maybe that are coming from other protocols. There are some types of metrics that are coming from OTLP that cannot be very well represented in Prometheus, or there is not a good way to do this currently with the exporter. So these data points will be dropped by the exporter. There are some common additional aspects that relate to also the difference in data model and how the data is transformed internally in the collector. Some of this were already mentioned here, but you should be aware of name and label normalization. So there are differences between, for example, the OTLP protocol and the OTLP format and the Prometheus format, where the OpenTelemetry uses dots to kind of denote the hierarchy in the name of the series, whereas, as we know, Prometheus uses underscores. So there is a whole package and a whole way how things are normalized for Prometheus. Another important thing is resource attributes, which also relates to the OpenTelemetry data model. Resource attributes are basically attributes that belong to an entity that produced certain metric or the resource in the parlance of OpenTelemetry. So for Prometheus, maybe we can make this analogous to the target. So these are certain metadata, I would say, about the resource that is originating the metric or the telemetry data. And here I have an example. Below you see this is how it would look on the debug exporter if I dump out some resource attributes. So this can be anything from, like, you see, if I'm running there in Kubernetes, I have Kubernetes pod, UID name. If you would run on a host, you might have the name of the operating system there. If you're running in cloud, you might have your cloud provider name, region, whatever it's related to those resources. Now the question is, how do we deal with this in Prometheus, right? Because we don't have this notion of resource attributes in Prometheus, and as was already touched upon yesterday, we can either you have possibility in collector either to send this into Prometheus as a target info metric, which is a special metric that will include these resource attributes as labels. Then you have to do a kind of awkward joins if you want to use those labels with your metric, or you can add those labels, those resource attributes as labels on your metric, but then you might overload the series with too many labels. So I think the good middle ground is here you can use the transformation processor, which makes it possible for you to maybe copy some of the resource attributes to the metric labels, but maybe drop the rest that you don't need, so you can filter out only the ones that are important to you. Unit and type suffixes, this is another thing where in Prometheus we're commonly used for unit and types to be part of the name, so we can have like underscore seconds, underscores total, but this is not how the OpenTelemetry data model represents units and types, or some information relating to types. So because this is actual part of the data structure for OpenTelemetry protocol, the unit and type usually would not be included in the name. So if you're exporting to Prometheus, again maybe from some other protocol, you might have to look out to make sure that the unit and types are added as suffixes to your metric names. Let's look at the operator. So OpenTelemetry project also includes an operator that's currently being developed and used. It manages auto-instrumentation, but most importantly for us now, it allows you to manage collector instances. It comes with a set of CRDs where you can define your collector instance in a CRD. Many different features. It supports rolling updates. There are multiple deployment modes. You can inject the collector as a sidecar. It supports horizontal auto-scaling. It's also installable via Helm charts. There's a whole Helm chart repository for this. And most importantly, for our uses, there is also this special component called target allocator that specifically works with Prometheus receiver. And it evenly distributes Prometheus targets among a pool of collectors. And then for each collector is then responsible for scraping subset of the targets that the target allocator allocates to that collector. This is then done via the HTTP service discovery. And even more interestingly, it can also discover and use Prometheus Operator custom resources. So if you have your service monitors, pod monitors defined, the target allocator is also capable of pulling these in and including them as the targets for scraping. For all of this, just a little teaser. I'll also be part of this tutorial session at the KubeCon NA. So if anyone who is there, you can check it out. It will go into much more details. So what to look out for? I mentioned now a bit about scalability and sharding. So this is possible with the operator and target allocator. You could shard and horizontally auto-scale the collector. We didn't mention rules or alerting at all. So if you're using the whole Prometheus server and not just Prometheus agent, this again, it's outside of the scope of collector because it doesn't have any querying or storage capabilities. So it might depend on your backend solution. Again, if you have some alerting or rule capabilities in your SAS offering, or if you're using one of the distributed versions of Prometheus, you need to make that shift. Data model differences, I already talked about what to look out for. Stability of components, this is also an interesting one because the stability is declared as beta, which you can read the definition here from the collector repository. So it sounds like it's usable, but maybe that reference to non-critical production workloads might make some people uneasy. But in general, it seems to be usable. So what is the conclusion? As we've seen, it's not super complicated if you want to go from Prometheus and use Prometheus receiver and Prometheus exporter. So if you make just the direct line between Prometheus receiver and exporter, you should end up with a similar experience as you would with, for example, Prometheus agent. As we mentioned, converting between protocols requires some more attention because there are some differences in data models that can also affect how your metrics will end up on the other hand, on the other side of the pipeline. Automation and migration also possible. You can look into the OpenTelemetry Operator. So I think in general, the collector is also usable for receiving and exporting Prometheus metrics. I think it's always good to look out for issues. There are here and there. I think there are still some bugs that needs to be ironed out. But on general level, I would say you can use this. So that is all from me. Thank you.
Hey, thanks a lot. That was pretty interesting. Great presentation. Does anyone have a question? Yeah, there we go.
Thank you for the presentation. I'm actually curious about when it comes to the usage in a cloud, for example, that there are several thousands of services that they are using some kind of client that ships data. When it comes to comparison with Prometheus, also for the client, but also for the collector, do you have any data for the comparison between those two when it comes into resources, like CPU, RAM usage, and if there is any other metric that you're aware about? Thank you.
Yeah, I was expecting this question, and yeah, I don't have an answer for that, honestly. So I think there are a couple of things that make it hard for me to like compare. Maybe first, there was a lightning talk by one of my ex-colleagues yesterday, by Daniel, who was doing something like this. If I remember, he was comparing Prometheus agent with doing the same with the collector, and I think the outcome of his experiment was that agent is obviously more, the Prometheus agent is more performant, so it loses less CPU and memory, but I think then you have to look at obviously how the Prometheus agent is specialized and how much work was put into it, and on the other hand, how the collector is much bigger, I would say, or much heavier piece of code with depending on also what kind of distribution of the collector you use and how many components you have there, and also what all of the things that you're doing with the collector, and not to mention how you scale the collector or how you use some of the tools that the collector makes it possible for you to, for example, limit the memory that the collector uses. So I don't have a good answer for that, and I guess there's still, if there are more data points or more comparisons available, I think that would be helpful if it's possible to make them on some reasonable level.
Okay, so we have one last question, and then we move on to the next talk.
So the question is focused on the collector operator. The Prometheus operator is starting to work towards the outscaling features, and ignoring that the Prometheus server cannot just simply scale down because we would lose data. Another challenge is reallocating the targets. So during the reconfiguration of the shards, do you see in the collector a strategy to not, the exact moment that we are reallocating targets, do we duplicate and scrapes a target twice by accident? Is there any logic to prevent that?
I think if that rise to it, I think that I'm not sure. I'm not aware of such issue.
Okay. Sorry, and thanks anyway.
Okay, thank you. So then, thanks again for the presentation.
Thank you.